So chapter 2 is going to cover systems of equations, and we're going to start with graphing, and then we're going to cover substitution and elimination, and then your third lesson will be a system of 3 equations. That lesson will be new as far as Algebra 2 goes, but these first 2 lessons of the chapter are Algebra 1 refreshers, okay? So this should not be too difficult. Vocabulary-wise, a system of linear equations is just a set of 2 or more equations, okay? For you to have a solution to a system, it has to satisfy both equations. If you have a system of 3, it has to satisfy all 3. If you have a system of 20, it has to satisfy all 20 for it to be a solution, okay? Now, when we get to classifying our systems, this is new, but you just have to memorize what the systems are, okay? So, your classification, if you have a system that has at least one solution, that's considered to be consistent. Okay? If you have a system that has exactly one, that is consistent and independent. If you have a system that has infinitely many, that's consistent and dependent. Okay? So those are your consistent options. Okay? So consistent is at least one. Consistent and independent is exactly one. Consistent and dependent is infinitely many. Okay? But there's a situation where you have no solution, and that would be your inconsistent system. Okay? So you will need to have that down, memorize it, whatever you need to do, because every problem we do for equations, you're going to have to classify. Okay? Now remember that when you're solving graphically, you're looking at where the 2 lines intersect. Okay? So for each problem, we're going to solve the equations for y equals mx plus b, which you should already be aware of. Your m is your slope. Your b is your y-intercept. Okay? Once you solve for y equals mx plus b, you're going to graph it, and you're going to see where they intersect. Okay? That point is your solution that you'll write down. If the graphs do not cross, you have no solution. So what type of lines are going to give you no solution? Parallel. Okay, and then if the graphs are the same line, that's when you have your infinitely many solutions. Okay, now we are going to have a few examples with absolute value again, so we are going to have to make t-charts for that. Now, when we start, we're going to solve, graph, then you're going to have 2 answers. You're going to have your solution and then your type of system, okay? So we're going to start with 4x plus y equals 8. I need to solve for y, so I need to get my 4x over to the right. I'm going to subtract my 4x, and y equals negative 4x plus 8. Okay? My slope is what? Negative 4, and my y-intercept is 8. So I'm going to plot 8 on my y-axis. Remember, your slope is your rise over run. So if it's positive, you go up and to the right. If it's negative, you go down and to the right. Okay, so I have a negative 4, so I'm going to go down 4 to the right 1. And I'm going to do quite a few dots because I want it accurate, because I'm looking for where they meet. Then once I graph that, I'm going to solve my second equation. So 2x minus 3y equals 18. I'm going to subtract my 2x. Negative 3y equals negative 2x plus 18. And then what do I do? Divide each term by negative 3. So y equals negative 2 divided by negative 3 simplifies to what? Positive 2/3 x. Then I have minus 6. So my slope is 2/3, and my y-intercept is negative 6. So from negative 6, I'm going to go up 2 to the right 3. And where do the two lines intersect? 3, negative 4. So that's my solution. That's the point that's true for both equations. So now I'll have to classify it. It has exactly one solution. So that would be consistent and independent. So what I usually say to keep them separate, the consistent and independent versus consistent dependent, is when you want to be independent, you want to be on your own. You want to be by yourself, okay? This solution is by itself. There's only one of them. It's alone, okay? So that's independent. Your dependent means you depend on someone else, and that's kind of like your IMS when it's the same line. They're dependent on each other to intersect. Okay, example 2, I need to solve for x minus 3y equals 8. So subtract your 4x, and you're left with negative 3y equals negative 4x plus 8. Divide by negative 3, and y equals a positive 4/3 x minus 8/3. Okay, so I have a slope of 4/3 and a y-intercept of negative 8/3. Okay, how are we going to graph negative 8/3? That's negative 2 2/3. Okay, so right about here. And so we're going to go from there and go up 4 to the right 3. So you're at 3 and 1 1/3, really. And then go up 4 to the right 3. So now you're at 6 and 5 1/3. Okay. Once you graph that, we're going to solve the second equation. Subtract your 8x and you get negative 6y equals negative 8x plus 16. Divide by negative 6. Y equals 4/3 x minus 8/3 again. What's going to happen here? It's the same line, right? So when it's the same line, tack on another set of arrows so you're indicating there are two lines here. And that is when IMS happens, my infinitely many solutions. So that would be consistent and dependent. We good? All right. 2x plus y equals 7. I need to solve, so I'm going to subtract 2x, and y is equal to negative 2x plus 7. My slope is -2. My y-intercept is 7. So plot 7. And then I'm going to go down 2 to the right 1. And then -2x plus 1, I'm going to start at 1. And I'm going to go down 2 to the right 1. What happens then? They're parallel. So that's going to be no solution because they never cross each other. So that would be an inconsistent system. We good? Okay. So now we've got y equals -2. What type of line is that? How do I graph that? Do I start at 0 and go down 2 to the right 1? It's just a horizontal line. Do not make the mistake of assuming that's your slope. You should be able to recognize when there's no x, that's a horizontal line. Okay, now we have absolute value. So I have y equals the absolute value of x minus 5. And remember, with absolute value, our vertex form was y equals a times x minus h plus k. Okay, where my vertex was where? HK. Your vertex is always HK. And what did I know about H? It was the opposite. Make sure you know that, because if you do not switch that sign, your table is going to be wrong. Therefore, your graph is going to be wrong. Therefore, your point of intersection is going to be wrong. Okay? So, a lot matters and depends on you knowing your vertex. Alright, so then my vertex is 0, -5. Okay, and the way I'm going to build my table, I'm going to take that vertex and do 2 points above and 2 points below. So, I'm going to do -1, -2, and +1, +2. Okay? Then to get my y values, I'm going to take these x values and just plug them in to my equation. So I'm taking the absolute value of -2. I'm going to write it out just for your notes. The absolute value of -2 minus 5. So that's 2 minus 5, which is -3. And then I've got the absolute value of -1 minus 5, which is 1 minus 5. So -4. Y'all follow me how I'm building this? Okay. And then I'm going to take the absolute value of 1 minus 5, which is -4. And the absolute value of 2 minus 5, which is -3 again. What happens here? I have two solutions. I've got -3, -2, and +3, -2. So, since I have 2, it's just going to be a consistent system. You good with that? Okay. All right, example 5. Absolute value of x minus 2 minus 1. I'm going to start with my table. What's my vertex? 2, -1. So then I'm going to have 1, 0, and 3, 4. Okay, and we can just use our calculator, or you can do it in your head. But calculator-wise, remember, math to the right gets you your absolute value bars. And so you're going to plug in 0 minus 2, and then minus 1 outside the bars, and you get a 1. Go back and grab it, and you get 1 minus 2 minus 1, which is 0. So the next 3 should be 0, and 4 should be 1. Do y'all understand how I got those? Okay. So now for -4x plus 3y equals 3, I'm going to add my 4x, and 3y equals 4x plus 3. Divide everything by 3, and y equals 4/3 x plus 1. So my slope is 4/3. My y-intercept is 1. What's my solution now? As an ordered pair. 0, 1. And that will be consistent and independent. Okay, we good with equations? Now we're going to move on to inequalities. Okay, so now we're still getting in y equals mx plus b. We have to consider dashed and solid lines and shading because inequalities are not one specific solution. It's a range and a variety of solutions that could be true. Okay, so remember that when you're doing inequalities, you have to shade. Okay, that shaded region is your possible solution area. So since we're doing a system, you want it to overlap. You want to see where those two shaded areas overlap. Then anything that falls in that region is your solution. Okay. If there isn't an overlap shaded region, then there's no solution. Okay, and then I put on your notes how to know if it's a dashed or solid line. So if it's less than or greater than, it's dashed. If it's less than or equal to, greater than or equal to, it's solid. Okay, so basically, if it has a solid line on your inequality, meaning equal to, it's a solid line on your graph. Okay, now shading wise, if I have less than or equal to, I'm going to shade below the line that I draw. If I have greater than or equal to, I'm going to shade above the line that I draw. But if I have a vertical line, I don't have above or below. I have left and right. Okay? So if it's less than or equal to, it's going to be shaded on the left. Less than left. Okay? If it's greater than or equal to, it's going to be shaded on the right. Okay? So this is where I do colors just so I can visualize it. And I put a little dot just to color code what equation goes with which graph. You don't have to do that. Okay? So here I've got y is greater than negative 2x minus 5. So my slope is negative 2, my y-intercept is negative 5. So I'm going to start at negative 5 and go down 2 to the right 1. Then I'm going to decide, is it dashed or solid? My inequality is greater than, so that's going to be dashed. And then greater than, I'm going to shade above. So if you have a hard time deciding what's above and below, go to your y-intercept, and if it's above, you go up, and that's your area. If it's below, you go down, and that's your area that you shade, okay? Greater than, I'm going to go from my y-intercept, and I'm going to go above it. So this whole area would be shaded. And I'm going to lightly shade it. I don't want to get crazy, okay? I'm going to lightly shade it so I can still see what I'm doing for the second inequality. So now I have a y-intercept of 3, and my slope is 1, so I go up 1 to the right 1. This time my line is going to be solid, because it's less than or equal to. Okay, so I go back to my y-intercept. It's a less than, so I'm going to shade below. Okay, and I can see where my two colors overlap. Okay, so I'm going to go back in, and I'm going to shade that darker. You can either highlight it, draw an arrow, shade it darker, whatever you need to do to indicate that's your solution area. So what that means is any point, any ordered pair I choose in this shaded area is true for both inequalities. So when I'm grading, I'm going to be looking at, did you graph your line correctly for one? Did you do dash versus solid correctly? And then did you shade correctly? Because there's nothing to write down. Okay, so now example 2, I've got the absolute value of x plus 4. Absolute value needs a t-chart. What's my vertex? Negative 4, 0. And so I'm going to have negative 5, negative 6, negative 3, negative 2. Okay. What is the absolute value of negative 6 plus 4? 2. What's the absolute value of negative 5 plus 4? 1. What's the absolute value of negative 3 plus 4? 1. And the absolute value of negative 2 plus 4? is 2. And then this is going to be a dashed boundary line. And then with absolute value, I go for my vertex. If it's greater than, I'm going to go up still. Less than, I'm going to go down. So I have y is greater than, so I'm going to go from that vertex, and I'm going to go up. So essentially all this inside the V will be shaded. If it were less than, it would be everything on the outside. And then y is less than or equal to 3. That's a horizontal line. It's solid. And it's shaded where? Below. So my overlapped region is this little triangle. Good? Okay. So now I've got y is greater than 2/3 x plus 2. So I'm going to plot 2 on my y-axis, and I go up 2 to the right 3. Dashed or solid line? Dashed. Shaded above or below? Above. Then I have y is less than or equal to 2/3 x minus 1. So I plot -1 on the y-axis, and I go up 2 to the right 3. Dashed or solid line? Shaded above or below? Below. Do I have an overlap shaded region? No. So my answer would be no solution. So you're not going to write anything unless it is no solution. Okay? So next example, I've got x is less than or equal to 2. So I've got a vertical line that's solid. Shaded where? Left. Then a horizontal line at -1, that's also solid. Shaded where? Alright. Now, I've got -y is greater than 2x plus 4. What am I going to do with that? Divide by -1. Y is now less than -2x minus 4. Remember, when you divide by a negative, your inequality sign has to flip. So I plot -4 on the y-axis, and I'm going down 2 to the right 1. And this line will be dashed. And where am I going to shade? So bottom would be below because it's less than. Can you tell where the 3 overlap? Should be this bottom left. But be careful, you're not going any higher than that horizontal line, and you're not going any further than this vertical line. Alright, so now I have 2x plus 3y is less than 6. Subtract your 2x. That leaves me with 3y is less than negative 2x plus 6. Divide by 3, and y is less than negative 2/3 x plus 2. Put 2 on your y-axis, and you're going to go down 2 to the right 3. Dash your solid line. Shade it above or below? The next one, y is greater than or equal to negative 2/3 x plus 4. I'm going to put 4 on my y-axis and go down 2 to the right 3 again. This one's going to be a solid line. Shaded where? So then my third equation, negative 2x plus y is less than negative 2. I'm going to add 2x, and y is less than 2x minus 2. Plot negative 2 on the y-axis. Go up 2 to the right 1. This is going to be dashed. Shaded where? Above or below? Below. So where's my solution area? Okay, so I have someone shaking their head no, and I have someone saying 2. Do I have are these 2 my solution area? What makes it a solution area? If they overlap, right? If I have a system of 2, it's where the 2 overlap. If I have a system of 3 like this, it's where all 3 overlap. Did all 3 overlap? No. So there's no point on this graph that's going to satisfy all 3. So that's where no solution is going to come back. So be careful, even though you might see some overlapping, you have to watch for all 3. Okay? You good with graphing? Alright, We're going to skip example 6 because I think graphing 4 is really not necessary. Okay? We're graphed 3, so I don't think you need to practice 4. Okay? But we are going to look at 8 and 9. Okay? When we have a graph and we have to come up with the inequalities, I personally like to highlight my x and y axis so I do not get that confused with all the other lines going on. Okay? That you don't have to do that. That's just a personal thing so I can see exactly what's happening. Okay? And then I like to number. I just start somewhere and start numbering clockwise usually, but this just helps you see my equation go with the proper line. Okay? Now, when you have a normal diagonal line, that's your y equals mx plus b. Okay? I need an m, which is your slope, and I need a y-intercept. Okay? So for this diagonal line, what's my y-intercept? 1. And what's my slope? -1. I'm going down 1 to the right 1. So for my first inequality, I know it's going to be y. To get my inequality symbol, I need to look at my shaded region in terms of this diagonal line. Is the shaded region above or below that line? It's above, so that means my inequality symbol would be greater than. And then my mx plus b, -1x plus 1. And then my second equation is my vertical line. Vertical line is always what variable? X. X is, I heard it, say it louder, less than, because it's shaded to the left of it. X is less than what? Okay. My third equation is a horizontal line. So that's going to be y is what? Greater than or equal to 3. Okay, I want you to do example 9, and then we're going to check it. You're all done? The vertical line. What should that inequality be? Okay. The line that's going in the positive direction. Y is less than 1/2 x. And then the third one. Very good. Okay, y'all good with that? Alright, so y'all's quiz is next class. Y'all are going to come in, take the quiz, and then since I won't be here Friday, y'all will watch the video of the lesson. over substitution elimination. Okay? That's Algebra 1 still. So not completely new.